On Tuesday, when we met last, we wrote down and talked about the fact that a mole is a counting unit. And that it represents, similar to how a dozen is 12, a mole is 6.022 times 10 to the 23rd units. And remember, those units can be atoms, they could be molecules, they could be particles, depending on what it is that we have. So this equivalence statement this equivalence statement, which means those two things are equal to each other, we can make that into a conversion factor. So our equivalence statement turns into a conversion factor. Actually, two conversion factors. So the first way that we could write this equivalence statement as a conversion factor is 1 mole of whatever it is per 6.022 times 10 to the 23rd units, whatever the units are. The other possibility is to flip that over, and we can equally correctly say there are 6.022 times 10 to the 23rd units per 1 mole of whatever that is. I would like to do 2 examples, but before we do those, I would like us to take a 1-minute brain break. Get up, move around, stretch your legs, and let's grab a water, something. I'm going to grab my paper that's on the floor. So here's our first example. How many molecules of glucose are found in 3.02 moles of glucose? So how many moles of C6H12O6 are found in 3.02 moles of C6H12O6? And that is glucose. I'm sure you remember that from biology, because I am sure that Mrs. Mansky or Mrs. Micas or Mr. Hughes all taught you that. Or Mr. Atchley. I almost forgot about Mr. Atchley. Okay. So, again, let's look at what we're given, and let's look at what we're trying to find. So we are given 3.02 moles. We want to know how many molecules. So we're going to always start with what we're given, 3.02 moles of C6, H12O6. Picket fence. Take this label, drop it on the bottom. Moles, C6, H12O6. Molecules, C6, H12O6 can go on the top because right here I've got my two possible conversion factors. So two things I want you to notice. One, whenever we're using moles, it has a 1 in front of it for now. Molecules or particles or atoms, that's going to be Avogadro's number, the 6.022 times 10 to the 23rd. Okay, this label crosses out with that label, and now I just need to do the math. This is on the top, so I multiply. And then technically, I'm supposed to divide by what's on the bottom. But because what's on the bottom is a 1, we're going to skip that. So type in your calculator 3.02 times 6.022 E. You're going to use that EE key. It's right there above the x to the negative 1. E23 equals. And then I got in my calculator 1.8186 times 10 to the 24th. Let's check our sig figs. 3 sig figs up here in my problem. So I need 3 sig figs here. Keep the 1, keep the 8, keep the 1. The 8 is going to make that 1 round up, so I've got 1.82. Don't forget the times 10 to the 24th. And then don't forget my label is molecules of C6, H12O6. Next example. We have example number 2. I want to know how many moles of, what do I want to use? Let's use uranium tetrafluoride, UF4. How many moles of uranium tetrafluoride are found in 4.926 times 10 to the 22nd molecules UF4? So how many moles of UF4 are found in 4.96 times 10 to the 22nd molecules of UF4? So here's where we are. Let's analyze. I'm given some number with a label. This time, it's 4.926 times 10 to the 22nd molecules UF4. I want to know how many moles of UF4. So again, starting with what I'm given in the problem, 4.926 times 10 to the 22nd molecules UF4. Ultimate Fighter 4. I don't know why that just made me giggle and why I just thought of that. Okay, I take whatever label's here and I put that label on the bottom. Molecules UF4. I got molecules on the bottom, so I'm going to put moles of the same thing on the top. My number for moles is always 1 for now. And molecules, that is one of the labels where I use Avogadro's number. 6.022 times 10 to the 23rd. Avogadro's number. Now I am going to cross out my labels, use my calculator, and here's what I'm going to do. Technically I should multiply by 1 because it's on the top. I don't need to do that. But then I'm going to divide by what's on the bottom, which is that 6.022 times 10 to the 23rd. So let's do this carefully in our calculators. I really want you to be able to see. There we go. So 4.926 E22 divided by 6.022 E23 equals 0.0818000066. You have to use the E button when you're doing this, when you're dividing. Why? PEMDAS. If you do not use the E button, your calculator thinks you want to multiply and then divide, and your answer is huge and a hot mess. Okay. So 4 sig figs in my data. So my answer needs 4 sig figs. Ooh, this one's going to be weird. The leading zeros are not significant. 1, 2, 3, 4. So my final answer is 0.08180 moles UF4.